Alright, so we're starting a new chapter and about to start a new quarter. Chapter 4 is about triangles. So we're starting up with a warm-up here. Always try to pause and do the warm-ups, or do the warm-ups before you even get on the video. That would be a good idea. So always do the warm-ups before you get on the video. So here we have, it says factor. The factors are called conjugates. And so hopefully that reminds you of what you're supposed to do, but you just take the square root of that, and then square root of that, and then you take the opposite sign. And if you multiply those back together, you should see that you get that. The 7x minus 7x cancels out, and that's why there's no x term in the middle. Okay? And here, same thing, the square root of that. So it's not the same thing because there's a coefficient, but still there, we can take the square root of that and take the square root of that. And then we just write down the exact same thing, but with a plus. Okay, now up here we added an example, x squared minus 3. And so when you first look at that, you might think, well, that doesn't really fit the pattern. But we can take the square root of x, and actually we can take the square root of 3. So the square root of 3 is the square root of 3. So if you were to multiply those back together, you'd get x squared minus 3. Because when you multiply a square root times itself, you just get the number. Alright, so we're going to start reducing some radicals, and usually on a test we would have 5 just like this. I'm not sure if we'll keep doing that or not, but we will be having some sort of questions like this. So you are looking for a perfect square factor that goes into both of those. So again, I hope you've done these already and you're just checking them now. Pause the video as needed. So here's a list of some, oh, those are perfect cubes. Wonder why we had that in there. None of these are cubed. Interesting. Alright, so here, the problem here is that some of you might have chosen 9 and 8, which is not a big problem, but the issue is that 8, you could reduce 8 again. So if you were going to do that, really, with 4 and 2, then it would be maybe nicer if we would recognize that we had 36 and 2, and we could just go straight to 6 root 2. Now that was fast, but you were supposed to have tried it yourself. Pause the video. So this is really going to help you in Algebra 2. We have a nice technique on how to do this. So let's see how that goes. So we talked a while ago about a radical could be thought of as the 1/2 power. So we would have x cubed y to the 6th to the 1/2 power. Okay? And when you raise a power to a power, you can multiply. So if you multiply that, you're going to get x to the 3/2 and y to the 6/2. And we're getting closer here. So that is going to be x to the 1.5, and this is going to be y to the 3rd. Now, any whole number you have, that's going to come out of the square root. So you think about it like this is an oven, and to be done, it has to be a whole number. It has to be whole. It has to be complete. It has to be done. So we'd take out the x to the first power, but when I take out x to the first power, I just write it as x, and then y cubed, and then any fractions, they're not done yet. So x to the 1/2, that's not done. So that needs to stay in the oven. That needs to keep cooking. Okay, it's not whole yet. It's not ready to go. So whole numbers come out. We don't really write x to the first power. We just write x. Okay, over here we have a 2 on the outside. We're going to leave that there. The 45, we need to separate that into a perfect square, so that's 9. Always put the perfect square before whatever's left over. Now this is a little tricky here. Some students make an error. This is times. So that's 2 times 3, not 2 plus 3, 2 times 3. So that should be 6 root 5. Okay? And lastly over here, there should be an obvious perfect square in there. I hope everybody sees that. It's going to be 100 times 5. So that's going to be 10 root 5. Okay? So if we were in school, I'd be in a shirt and tie a little bit more often, but in the empty room here, I've been wearing a lot of polos. So, not that that matters all that much, but just so you know. All right, triangle sum. So that's the warm-up. Triangle sum theorem. That's very important. Sum is the answer to an addition problem. So the triangle sum theorem says something about triangles. So let's see. Let's do this. So if you look at that, you should see that angle 1 and angle 5 are going to be congruent because parallel lines mean that alternate interior angles are congruent. So those two are congruent. Now, if we look on the other side there, angle 2 and angle 4 will be congruent for the same reason. So, this angle inside the triangle is congruent to that angle, and this angle is congruent to that angle. So that kind of shows you that these three angles add up to 180. And that's what the triangle sum theorem says. So it says the three angles of a triangle sum to 180 degrees. So that's something that we want to commit to memory. All right? Now, the next thing we want to talk about is classifying triangles. These should be easy points for you. We classify triangles two ways. So one way is based on the sides, and the other way is based on the angles. So on a test, if we ask you to classify a triangle, we probably want you to say both, but I'm not positive how the questions are formatted in the different things that we have, so we'll see. Okay, so equa means equal, and lateral means sides, so this means equal sides. So an equilateral triangle is a triangle where all three sides are equal. Isosceles has two equal sides. Okay? The base is the side that's not equal. The two sides that are equal are called the legs. Iso means same. Isosceles means two sides the same. Scalene means no equal sides. Okay, so you need to memorize that vocabulary. Those should be easy points. Now, if we move over to the angles, acute. Acute means all the angles are acute. Right means there's a right angle. You can only have one right angle in a triangle. So the two sides that are perpendicular are called legs, and the side across from the right angle is called the hypotenuse, the longest side of a right triangle, the hypotenuse. And down here we have an obtuse triangle. That just means that there's an obtuse angle. If the angles add up to 180, we can't have more than one obtuse angle. Same reason we can't have more than one right angle. And equiangular is a special kind of acute triangle. Maybe I should put that arrow going the other way. And equiangular is an acute. All equiangular triangles are acute triangles. Not all acute triangles are equiangular. And if you think about it, if the three angles add up to 180 and the angles are all equal, then they're all 60 degrees. And equilateral triangle is also equiangular. So those two go together. Okay, so classify the triangle. So we have to classify it two ways, sides and angles. So sides, if you look at this, if those are both 60, 60 plus 60 is 180, or is 120, and 180 minus 120 is 60. So this is also 60. So that means it's equilateral and equiangular. Now I don't have to say acute, because if it's equiangular it has to be acute, because if it's equiangular they're all 60. So equiangular is more specific, is a more specific answer than acute in this case. Okay, using vertex A, name sides that are adjacent to angle A. So if you're adjacent to it, it means you're part of it, you're right next to it. So that would be segment AB and segment AC. Those sides of the triangle are adjacent to angle A. And the opposite side is BC. All right? Adjacent. This is adjacent to A. This is adjacent to A. This is the opposite of A over here. All right, corollary to a theorem is a statement that's proved easily from a theorem. So if we have a theorem, a corollary is something that's easy to prove based on the theorem that we have already. Okay, exterior angle theorem says that the measure of an exterior angle, okay, let's see what color do I want to use for that. So an exterior angle of a triangle, so I'm going to put that in green out here, and that's angle 1. Okay, so the measure of an exterior angle of a triangle, that's an angle on the outside, the exterior of your house is the outside of your house. The measure of an exterior angle of a triangle is equal to the sum of the remote, non-adjacent interior angles. Okay, so remote. So if you think about it, like you have a remote control for your television, right? Cable, whatever. So what does that remote allow you? The remote is far away from the TV. It lets us control the TV from far away. Okay? So that's why it's called a remote. It gives us remote access. It allows us to access the television without being right next to the television. If any of you have parents in the military, you might have heard of remote assignments. My dad was in the military for 20 years in the Air Force, but he never had a remote assignment where he had to. A remote assignment, usually they go by themselves. Families aren't allowed to come. There's just not a lot of facilities out where they are. So that's way out there, remote. Okay. So now let's look at, so where is ACB? ACB is right here. Okay. All right. So what this is showing us, well, let's look at what we have going on here first of all. So this is saying that these three angles inside here add up to 180. So based on today's lesson, hopefully you can think of a reason. How do we know that the two blue angles plus the pink angle equals 180 degrees? Well, that's the triangle sum theorem. Okay, so hopefully you know that from that. Now, if we come over here, how do we know that this plus this equals 180? Well, hopefully you see when we have two angles that are adjacent, they share a side, and they form a straight angle, that's the linear pair postulate. Now some of you kind of mix it up and some of you say, oh, they're supplementary. They are supplementary, but they're supplementary because they are a linear pair. So the linear pair comes first, and then that says that the angles are supplementary. Okay. Now, we have this plus this equals 180, and we have this plus this equals 180. So this part's the same. So if that part's the same, then that means that these two have to be equal to each other. Okay? Because 180 minus that will be the same number, and so these two things will be equal to the same number. And we don't need a reason over here. These we're just using that as a review a little bit. Okay, find the value of x Then find the measure of the exterior angle. Okay, well this is just illustrating exactly what we have up here. This plus this equals this. This plus this equals that. So in our equation here, we would say x plus 72 equals 2x minus 11. Okay. Then we would subtract x from both sides. That would give us x. And then we would add 11 to both sides. So x equals 83. Now, I don't really need to put degrees there because there's a degrees here on x. Alright, so the direction said find the value of x, which we did, and then it says find the measure of the exterior angle. So, the easiest way to do that, we could plug 83 in for x right there, multiply that by 2 and subtract 11. Or, if x is 83, then the easiest way to find that actually would be to add these two together. So we would have 83 plus 72. So that's going to be 155 degrees. Then find the measure of the angle. Alright? Okay, the measure of an acute angle of a right triangle. Okay, blah, 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 blah. So, right triangle. So we've talked about many times that it's a good idea to sketch a picture, especially in geometry, but really a lot of math classes, there's times where it's good to draw a picture. Okay, so the measure of an acute angle, both these angles are acute, is 1/4 the measure of the other acute angle. So one of the angles is going to be x, and the other one is going to be 1/4 of x. Okay? So it says find the measure of each acute angle. Well, there's a couple different ways we could do this. We could do this plus this plus this equals 180. That's one thing we could do. Or, if you think about it, 1/4 x plus 90 equals 180. So then if you subtract 90 off of both sides, these two must add up to 90, which hopefully makes sense to you because 180 minus 90 is 90. And we already have 90, so these two must add up to 90, so that it adds up to 180. Alright, now what I tend to do most of the time when I have a fraction is I clear the fraction. Clear the fraction. So we clear the fraction by multiplying by the common denominator. So I'm going to multiply the whole thing times 4. Sometimes I get like terms together first, it just depends. So 4 over 4 is 1, so that's just going to be x plus 4x equals 4 times 90. Okay? Now I could multiply those together right away, but maybe something will simplify. If I add these together, that's 5x equals 4 times 90. Divide by 5. Okay, so here's where it's kind of up to you what seems to work the best. 100 divided by 5 is 20, and 90 is 2 less 5s, so that's 18. So 5 goes into 90 18 times. And you might not have thought of that. You could just multiply it out, or you could do long division. You could multiply that first to get 360, and then divide that by 5. You have some choices. So, excuse me. 40 plus 32 is 72. Okay. Now, the question actually asked you for the angles. So, it wants both of these angles. So, one of the angles is 72. The other one is 1/4 of 72, or 90 minus 72. So, the answers are 18 and 72. Alright, corollary to the triangle sum theorem. So this is something that's easy to prove from the triangle sum theorem that we already mentioned. The acute angles of a right triangle are complementary. I just talked about that for a bit here. That's 90. The whole thing's 180. So if we subtract 90 from both sides, then these have to be 90. So that's what this says. Oh, excuse me. All right, classify this triangle. So remember, we're trying to classify it two ways, sides and angles. So at first, look at the sides. That should be pretty easy. That's going to be scalene. None of the sides are equal. And you see this down here, so that should be pretty easy also. That's going to be a right triangle. Okay. Why is there no base? Well, normally, we could talk about base times height, something like that, but because it's not isosceles. Isosceles triangles have a base. All triangles have a base if you're finding area, but okay, construct an equilateral triangle. So what we're going to need to do here is an equilateral triangle has 3 equal sides, so we need to start off with a side. So I'm going to make that side 2 inches. Can't see that. While we're doing that, let's look at the cartoon there. And the cartoon says, teacher telling a student, and he says, no, 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 acute triangle, like this, said Mr. Armstrong's final geometry class before forced retirement. So he had to retire. So he made it a cute triangle and put a little bow on it and stuff. Oh, that's a cute little triangle. Not that funny, but when you're educated, sometimes you can make a choice whether something's funny. Some people just don't get it, and they don't know whether it's funny or not. But as educated people, we can look at it and say, you know what, I know what an acute triangle is, and that's not that funny. But at least we know what the joke's about. So we can decide if it's funny or not to us. Okay. So, an equilateral triangle needs 3 equal sides. If I take my compass, a compass in the olden days was also a measuring tool. So it allowed us to measure this and say, well, it's that long. That's how long it is. Now, I didn't do this very well, but so if I start to draw a circle around one of the endpoints of that line segment, I get an arc up there. And if I do it again from this side, what happens is that length is the same as this length. So what I've done now is I've created the third vertex. It sounds like that could be a movie, the third vertex. Or maybe not, probably not. Anyway. Alright, so now if we just connect that back to the original 2, then we get an equilateral, equiangular triangle. Wish I would have moved that down just a little bit. Okay, so that is that lesson, but now we have some review stuff at the end here. So this is something that we've put on some tests before. I don't think we probably won't have it on the test in the same format, because I don't know that Alex or Canvas. I mean, Canvas, I guess we could make something like this, but okay. So the first thing we're trying to do is we want to figure out which lines are parallel and which lines are perpendicular. So to do that, we want to know what the slope is. Now, we don't always give you a little line for the slope here, but that's what we're trying to do here. So hopefully you see this and immediately you recognize that as point slope form. So you say, okay, yeah, I know what that is. All right. So there's the slope. So the slope is -2. And this is in slope-intercept. Now this is review, so you guys should be able to pause this and do the whole back page by yourself right now. But if you want to, maybe just unpause it and watch like one line at a time or something. Or you can do the whole page and then it's up to you. So that's -1/2. Now here, y is not by itself. So I would add 4y to the other side and subtract 16 and flip the whole thing over. Or subtract 6, sorry. So I would add the 4y over there, subtract the 6, and then flip the whole thing. Then I'm going to divide by 4. Now I can pretty much stop here because all I care about once y is by itself is the number in front of x. But just to make it look mathematically correct, I'm going to do that as well. But I'm not even going to do anything with that. All I'm going to do is focus on this, and that's going to be 4. Okay, x equals 2. That's a vertical line. And vertical lines have undefined slope. How can you talk about rise over run if it's not moving over at all? Okay, here, that is slope-intercept form. Slope is 2. Here, we need to subtract 16x from both sides and divide by 8. So all we care about is what's in front of the x when y is by itself, which it is now, so that's -2. And here again, that's -2, that's in slope-intercept form, it's right there. And finally, this last one is a horizontal line, and that has a slope of 0. And that's actually okay. Okay, so which lines are parallel? So parallel lines are have equal slopes. So that looks like A, F, and G, alphabetical order. All right. Now, which lines are perpendicular? Perpendicular are opposite reciprocals. So first of all, we have these two. Those are opposite reciprocal. Opposite meaning positive and negative, reciprocal meaning flipped. So B and E are opposite reciprocals. Now, down here, D and H, that's just horizontal and vertical are perpendicular to each other. Always. All right. So the first one says slope-intercept form. That's y equals mx plus b. So that's the top two. So I would start all these off with point slope form anyway. So I'm going to go y minus 2 equals m times x minus x, which would be minus a -7. I should have put minus a -7. So since they asked us to do slope-intercept form, I would have to distribute, but it's just 1, and that would be the plus 7 there. And then add 2 to both sides, so that would be plus 9. Alright. Now, here we have a point, and they tell us we're parallel to this. Since we're parallel to this, all that means is we want that slope. I don't care about any of those other numbers. So again, I'm going to do the same thing I did in the last problem. Try not to look. I'm going to try to remember. Y minus y equals m times x minus x. Pause. Don't just sit there and copy us. Subtract 7 from both sides. There you go. Okay? Now, a couple things here. First of all, the directions say point slope form. Okay? So, in point slope form, I started both those other ones in point slope form. So in point slope form, what we want you to do is we always want you to use the first point. Always use first point. Okay, so it's going to be y minus, this is a little awkward with a 0, but y minus 0 equals x minus 1. Okay, and I could have just started with that down here since the directions say point slope form. So that's what I should have done. Okay. You don't need to write that out twice. Okay. So what we need here though is the slope. We need to calculate the slope. So that is y2 minus y1. So that's -6 minus 0 over -2 minus 1. So that's going to be -6 over -3, which is 2. Okay? So hopefully you're trying this by yourself and not just copying point slope form. Directions say point slope form. Notice how all of them point slope form to start with. So y minus y equals m times x minus x would be minus a -2, which is x plus 2. All right, now the trick here is perpendicular to this. So the slope of this is -5. The slope of the perpendiculars are opposite reciprocals. Opposite reciprocals. That's what I said up there when we were identifying the slopes that were opposite reciprocals. So this is negative, so the opposite to that should be positive. And this is actually technically 5/1, so the reciprocal of that would be 1/5. So that's going to be 1/5. And that wraps up our first lesson of Chapter 4. So come to office hours if you need help, get involved, and I'll see you next time.